Hi, and welcome to Kloeker's Education Foundation, where we provide quality content for amazing teachers and students. If you are coming from our last video on ecosystems, the weather, climate, and the environment, welcome. We're glad you're back. If you're joining us for the first time, this is our World Geography series, and today's focus is on inside the Earth. Don't forget to check out the link in the description below to free guided notes. Now, before we dive into planet Earth, let's talk about our solar system, the sun, and the 8 known planets, and of course the other bodies that orbit the sun as well. Earth is the only planet that people can live on, right? We're just the right distance from the sun where we have a sustainable temperature. Pluto, growing up, Pluto was considered a planet. However, scientists took that designation away because it does not dominate the neighborhood around its orbit. Furthermore, its orbit actually intersects the paths of several planets, which could cause for some collisions down the road. Now, there are 7 major continents on planet Earth. There is North America, Latin America, Europe, Africa, Asia, Australia, Oceania, and Antarctica. Inside the Earth, there are several layers. Okay, there is the core. We have the inner core and the outer core. These are the innermost layers, as you can see on that picture on your right. Outside of that, we have the mantle. Okay, a soft layer of about molten rock, several hundred miles thick. And then at the very top, we have the crust. This is, of course, where we live. We live on the crust of the planet. Now, the thin layer that we just talked about, of course, we have the oceanic crust, which is the ocean's floor, and we have the water on top, and we have the continental crust, which is the parts that extend above sea level, and that is, of course, where we live. Inside the Earth, there is this thing known as magma. This is molten rock inside the Earth. It is magma once it is inside the Earth. It is lava once it is outside of the Earth. But let's take a look at this diagram real quick. So we have several layers. Underneath the crust, we have the lithosphere, the asthenosphere, the mantle, the outer core, and then the inner core. When I was in high school, my lovely geology teacher says Lemoy is a great way to remember all of the levels or all of the layers of the Earth. Lithosphere, asthenosphere, mantle, outer core, inner core. Now the crust that we live on is actually incredibly thin. It's just about 20 miles or 40 miles in some places thick. And so it's kind of incredible that we live on just this thin layer of not molten rock. Now on the crust, there are several spheres, right? We have the hydrosphere. This is the water portion of the Earth, the lakes, the rivers. We have the lithosphere, that solid layer of rock. We have the atmosphere, right? The gases that are from the crust through the ozone, and the biosphere. This is where plants, animals, and people live in the biosphere. Now, in 1912, Alfred Wegener, a geologist, presented this idea that all of the continents were once connected together, that Earth was dominated by a supercontinent known as Pangaea, and that because these continents are drifting apart, this is going to cause them to separate into what we know as the modern continents. So according to this theory, as you see in the top left, Pangaea was all together. Pangaea coming from the Greek words of pan, meaning all, and Gaea, meaning earth. All earth was together, and then we separate several hundred million years ago. We've continued to separate it and continue to separate it until we have our modern day continents and their locations. And under this, that we are continuing to drift, they will continue to drift and eventually all once again collide, forming a second Pangaea. Now, fortunately, that collision is suspected to be hundreds of million years away, so we don't have to worry about that. However, there is quite a bit of evidence to support Wegener's claim that our continents were connected. You can look and see South America and Africa look like they would fit two pieces of a puzzle, very close together. Several fossils have been found that have extended into South America and Africa, into India, Antarctica, and Australia. Again, all of these fossils and the remains suggest that at one point in time, all of this landmass was indeed connected, and these lovely little critters that roam the earth would have one giant land to roam and control. And of course, this is why fossils are found everywhere. So Pangea, Antarctica being there at the bottom, we were all together, South America, North America, Africa, India, Australia, and Eurasia were all there, and we've continued to drift out. India, being its own separate continent at this time, would drift up and collide with Asia. We'll talk about that in a future video. But we're all together under Wegener's theory. South America and Africa are not the only places where they interlock and geology suggests that they were once connected. As a matter of fact, North America, the Appalachian Mountains or Appalachian Mountains model the mountains found in Ireland, Scotland, and all through Scandinavia, the Caledonian Mountains, to suggest that at one point in time they were all indeed connected through Pangea and were separated in the continental drift. And so there are two major connections, South America and Africa, and of course the mountains found through Europe and North America. Now, Wegener's theory is known as plate tectonics, so let's talk about that for a moment. Plate tectonics is the theory that Earth's crust is broken up into several different, quote, plates that are moved around by the currents in the mantle, and that they collide and intersect with each other, and they will continue to move around and shuffle like a puzzle pieces that will interact by themselves. Okay. North America, we have the South American plate, Africa, the Arabian plate, the Indian plate, which has collided with the Eurasian plate, the Somali plate, which is supposedly drifting away from the African plate towards Australia, and then of course we have the Philippine plate, which is very conveniently named, but the Philippines is not in the Philippine plate. Right, again, just a portrayal here. The Philippines is, of course, on the edge of that Philippine plate, but that all of these plates are rising, sinking, colliding, and shuffling around due to the currents in the mantle. Now, the currents in the mantle are several 100,000 miles deep, and so we can't exactly study a whole lot of them besides looking at where the plates have been and where they are going. So these enormous pieces of Earth's crust are floating on this molten rock and shifting. That is, of course, plate tectonics, and the tectonic plate refers to an individual plate sitting on that magma. So the currents. We are aware of different types of currents, right? Again, based off of how our plate tectonics are moving. We have a convection current formed when heating is rising, right? This would be a volcano, and because the heat is rising, it is going to separate. You see there, right there at the middle, the oceanic ridge, pushing two plates away from each other. We're going to talk about different types of collisions and boundaries here in just a few seconds. A few seconds later. So, if they are constantly moving around, what happens when they meet? These places where the plates meet and collide, these are known as plate boundaries, and there are several different kinds of plate boundaries. First, we have a divergent boundary. this is where two plates are moving away from each other. So generally there's lots of active volcanoes. The Somali plate and the African plate are drifting, causing a rift. We'll talk about that in a few slides too. They're moving away from each other. Now, in contrast, we have a convergent boundary. This is where two plates are colliding, because again, all these plates are interconnected, so when one pushes, one has to move too. These two plates are colliding, and we see it again. When two plates collide, they are either going to collide and push up the land that was existing there. Okay, this is an example of India colliding into Asia. We have the Himalayan mountains, mountains that are continuously growing because that plate is continuing to push up and up and up into Asia, and eventually will be underneath the Asian plate or the Eurasian plate. And we have the convergent where it is being subducted or going under the plate that's already there. Now, an example of the convergent plate is going to be Latin America. Latin America has stayed still, as you can see, it's kind of like the left-hand side of this graph, and the Pacific plate is floating, and because it is already heavy and there's water and it's soaked, it is sinking, and it's actually pushing to an extent the Latin American plate up. The Andes are continually growing as well, at a much slower rate, of course. Now, not all plates are colliding and separating. Some plates are rubbing against each other in opposite fashions. Okay, this is a transform boundary. Okay, where two plates are sliding past each other. Generally, we have lots of earthquakes when this happens because that friction is them shuffling, and every time they snap and move an inch, that's hundreds and hundreds and thousands of feet underwater. That giant force of energy is causing tsunamis and earthquakes. Of course, we have it where some plates are going to be separating, whether they're going to be separating going left to right, or they will be separating because one will be moving up and one will be moving down. Okay, we have different types of faults or the cracks in the Earth's crust because of our plate tectonics. Now, because of plate tectonics, we have earthquakes, right? That giant snap of it takes a lot of energy to move a continent, even a few inches. So that energy, when it snaps, is released either up, down, out, and can cause a giant crack through the Earth's crust. We see it in Turkey all the time. We see it in India. We see it in the Oklahoma. We see it in lots of places where we have fault lines. We also see it when it's underwater. That causes tsunamis. We'll talk about. Now, when an earthquake happens, wherever that snap point is, whether it's on the surface or whether it is hundreds and hundreds of feet below the crust, right? If it's on the ocean floor, wherever that snap point is, that's known as the focus. And the point directly above that, okay, on the surface, that is known as the epicenter. Okay, so the focus is generally below ground. The epicenter is above ground. There are some more terms that you need to be aware of. Again, I talked about this earlier in the video. Because of the convection, right, we have lots of molten rock. When that molten rock is below the Earth's surface, that is magma. When it is above or at the surface, that is lava. The only difference is where you find it. Kind of like the difference between a buggy and a shopping cart. It's the same thing, it just depends on where you are. Another term that you need to be familiar with, because we have volcanoes and we're talking about the shifts in the Earth's crust, the pyroclastic cloud. This is, of course, all of the gases and rock that are ejected out of a volcano when it erupts. And it, of course, is going to fall down. All that smoldering ash, that is part of the pyroclastic cloud. Not all volcanoes are above land, though, right? We've talked about the Ring of Fire, El Nino. We have it all the way around the Pacific Ocean. these volcanoes because, again, we have our continent shifting, right? When they are spreading and spewing magma, lava, they are pushing, creating new land, they're pushing those plates to the left or to the right. So those hot spots cause the development of some places known as islands. There are different types of islands. We'll talk about that in a future video. Okay, we have archipelagos, which are kind of developed by coral, and we have volcanic islands. These are developed by volcanoes, as the name suggests. Places like Hawaii, that is a volcanic island, right? The hot spot is where that crust is broken by the volcano and where that lava is coming up, that hot spot, to develop the island. Okay, all of Hawaii's islands were developed by the same volcano, and there are several more islands in Hawaii that are underwater, and they didn't have enough lava magma spewed up, molten rock spewed up, in order to breach the oceans, to breach sea level. So weather can play a huge role, right? Because we have these mountains, but we also have things wearing down mountains, and that's known as weathering. Okay, weathering, the physical, the chemical processes of changing the characteristics of rocks on or near the Earth's surface. Okay, we have regular rain, we can call that erosion. The ocean's currents will, of course, chisel away from rock. If you've ever been to the beach or to the coast, you've probably seen some interesting rock formations that were developed by the water, by the ocean. Okay, that weathering is very important. Water, ice, rock, wind, all of this sand is blasting rock and eroding it, causing it to crack and crumble. This erosion, okay, not only breaks down rock, it's not just from the water, the precipitation that falls from the sky. Rivers cut through rock with enough time and force. We see that in the Grand Canyon, Colorado Bend State Park, Pedernales, if you're here in Texas. There's lots of places where the rivers have eroded a path through. And sometimes, unfortunately, the rivers have dried up and we're left with a path that was cleared by a river maybe 100 years ago, maybe 20 years ago, depending on the climate and the changes that have happened. So, weather erosion. Now, much like the phrase, what goes up must come down, erosion is not evaporating and disintegrating the material. That material has to be transported somewhere else. Okay, when a river flows through a canyon and a rock, it's picking up the silt, the rocks, the sand, and it's taking it downstream. Now, many times when these rivers hit the ocean, they kind of fan out again, water's taking the path of least resistance, and it will form out into a beautiful triangle type shape known as a delta. There are quite a few famous ones. We have it in the Amazon, we have it in the Nile, we have it in Southeast Asia where the river fans out in these patterns. Now, water is of course going to be one of the greatest movers. Wind is also going to be able to pick up and carry sediments, whether it's sand, it's that light particles of dirt and dust that are going to be carried from point A to point B. We have sandstorms, dust storms all throughout the planet, right? And wind is going to blow and pick up the sediment and carry it from point A to point B. Now, of course, when the wind picks up and carries the soil, it's not just always picking up soil. Very often it's picking up those microbes, the organic material, some plants and life that are traveling with it, and it is transporting them across the country to wherever the wind blows. And so we do have a constant level of dust and dirt in the air at all times because of our planet and the way it is built. Now, weathering occurs with all of this going on. Chemical weathering occurs when the rock changes into a new substance. Okay, rust on a car, for example, oxygen changes iron into rust, climatizes if you're in the Northeast, Cars generally have a lot of rust. I know several people that will leave and drive and buy their cars from places like Texas, New Mexico, Arizona, California, because there's not a lot of moisture, there's not a lot of rust in the salt in the cars, and they'll go back and take it back to wherever they live, whether it's Ohio, Pennsylvania, New York, etc. Those chemical changes, that is chemical weathering. Now, ice is another form that we haven't talked about a whole lot, so I'm going to end on this last few notes. Glaciers, right, the frozen masses of ice that are often pushed through canyons by wind, by currents, are going to chisel their way through the land. Okay, the Great Lakes were carved by glaciers a long time ago. The Scandinavian fjords were carved by glaciers a long, long time ago. That frozen ice is going to again act kind of like a chisel and carve its way through the rock, leaving these beautiful landscapes. Now, when a glacier melts, the rocks again, because it has to pick up and carry the items, the sediment, it doesn't just evaporate into thin air. What's left in the canyon, that is what's known as moraine, right? The hills, the rocks, the deposit, the soil left by the glacier after it melts. That wraps up our lesson. Thanks for joining us. Don't forget to like and subscribe. Our next unit on human geographic systems is just a click away. I'll see you there.